talking about functions within functions. So I just made this problem up. It's not in any of your packet. It's just straight up here. Here's f of x, negative 12 minus x over 5. Here's g of x, 3 over x. What I want to do is I want to find f o g. That's what we call it, fog, f-o-g, or f of g of x. So, no, that's something different, Madison. We'll get to that. Why don't we talk about that next? Okay. But anyway, let's do f of g of x. So, f of g of x is basically, if I told you what is f of 2, then all you do is you take this x, since you replace this x with a 2, all you got to do is replace everything in here with a 2. So it's 12 minus 2 over 5, which we know as 2, is equal to 2. Cool. So what if I replace this with a g? Well, that's pretty easy. That's just 12 minus g over 5. Are we cool? And then what I said next is I said, well, like I said, you can replace anything in here. It just means replace this thing with that same thing. And then what they wanted me to do was they said, well, this is actually what g is. So I'm going to say that's equal to 12 minus this over 5. And that is what f of g of x is. I think it's called a compound function. Cool? So, Bradley, I think that what you're saying, what you were confused about is that why didn't I just straight up write this down? And it's because I actually did a middle step over here. Yes, in the actual problem, they didn't give you a g of x, and I think that that was just a typo. They forgot to give that to you. I mean, technically, we could figure out what it is, but I just decided to make one up instead. All right. Keep in mind that f of g is going to be different, or usually it's going to be different from g of f. Because if I want to find g of f, that would be 3 over f, which is actually 3 divided by 12 minus x over 5, which is equal to 15 over 12 minus x. You guys see this? I got a fraction over a fraction. I just took this and flipped them over. So that way the 3 got multiplied by the 5, and that's where I got the 15. And then you notice that this thing is drastically different from that thing. So f of g is different from g of f. Are we cool? Now, Madison, which you were asking, can I erase this? Can I erase this? Okay. Madison, what you were asking is, if it just gives you these two things and it says a word like solve. And by solve, what it means is, it's saying, when do these things intersect? When are these equal to each other? So you're absolutely right. You would just set f of x equal to g of x. And I think, let me think, the graph of this thing right here would be something like, let's see, it's going to have us, I'm going to rewrite f of x a little bit over here. So this is f of x is equal to negative 1/5 x plus 2. Give me a second. What's 12 divided by 5? It's a decimal. I can't think of it in my head. 2.4. And then I'm going to rewrite g of x. G of x is equal to 3 times 1 over x. Okay. Here's what's going on. All right, do you understand how I got from here to here? All I did was I did 12 divided by 5 and x divided by 5. That's why that has the negative 1/5 x. And then I put the plus 0.24. I wanted to put it in the y equals mx plus b form, right? Where my slope and my intercept, boom, I've got it. And then over here, all I did was I just said, well, that's just 3 times 1 over x. The reason being is because I know what the graph of 1 over x looks like. It looks like this, right? And then I also know that a 3 out in front, that's my stretchy term, will make the graph look more extreme, like that, or something like that. It will stretch it. We'll pull these values over here. It should be symmetrical, so I should probably fix this. Something like that. All right, so that's the graph of G. The graph of F is this. It's at 2.4, and it's at negative 1/5, so something like that. So I suspect that there are going to be 2 intercepts, right here and right here. Or none. There could be none, depending on if I drew my graph accurately or not. But do you see how there could be up to 2 intercepts in this particular case? Well, if we set f of x equal to g of x, we'll have 12 minus x over 5 is equal to 3 over x. I'm going to cross multiply those things, and I end up getting x times 12 minus x equals 15. So 12x minus x squared equals 15. Guess what kind of equation this is? And what would I use to solve it? There we go. It's a quadratic equation. I would use a quadratic formula to solve it. I'm not even going to go through that because you guys know how to use that. But you can see immediately it's a quadratic equation. So you know that quadratic equations can have 2 answers. It could also have 1 answer, and it could also have none answers. But at least it kind of matches with my picture. Now, to be honest with you, I think that I've never really seen people, I mean, this could honestly easily be on your test. But when I've seen it say solve these 2 equations, I usually see a linear function equals to a linear function. And when you have that, then solving it is really easy, and that you only get 1 answer. Because it's saying, when does this line cross with that line? If you're talking about 2 lines, they'll never intersect at more than 1 point. Unless, of course, they're the same exact line. Does that make sense? Kai is saying, it's the quadratic equation, but I don't remember anything except this unsure dude with these chicks. Can I review completing the square? All right, good. Why don't I stop the recording? I'm going to start another recording, and then I'll